We want to solve this system of equations in the case, first of all, when b is 10, and secondly, when b is 12. So if we look at part A first, that's when b is 10, but let's just do it with the b here to start with. So what I'm going to do is eliminate z between these equations. So if I call this 1, 2, and 3, then if I do equation 1 plus equation 2, I'll get rid of z. So that gives me 3x plus y, z's go, is equal to 8. Let's call that equation 4. And now I'd like to get rid of the z between these two equations. So if I do equation 3, take away equation 2, that gives me 3x's. No y's take away negative y, gives me a plus y. Z's will disappear, and I end up over here with b take away 4. So let's look at the situation where b is equal to 10. That means that equation 4 is 3x plus y is equal to 8, and equation 5 is 3x plus y is equal to 6. Note how the left-hand sides are the same, but the right-hand sides are different. We say that these equations are inconsistent. And in this case, we get no solutions, and the picture is the Toblerone box, like so. We can see that none of these are parallel or anything like that, so it's like this, and we get no solutions at all. And the calculator knows this. That's that system, and it tells me no solution. Now for part B, we have that b is equal to 12, and in that case we know that equation 4 is 3x plus y equals 8, but equation 5 becomes 3x plus y equals 12 take away 4 is 8. These are the same. They're consistent equations, but because the left-hand side is the same, there's no way that we can eliminate x and y. And that gives us an infinite number of solutions like this, where the three planes meet in a common line. Now, by changing the value of b, all we've actually done is just shift the plane. So you can think of this plane here as being shifted in this way until it intersects with the other planes here, and that's how we end up with this. It's just like changing the intercepts on a straight line moves the line up or down. Changing the constant on this side will just move the plane along. Does the calculator recognize this? Well, yes, it does. If I just change this 10 here to 12, all of a sudden we start to get solutions. But note, this was different to when we had the plane of solutions. Here we've got z equals z, and x and y are stated in terms of z as a parameter. So if you think a couple of examples back where we had a plane of solutions, y was equal to y, z was equal to z, and x was in terms of y and z. Here, where we've got a line of solutions, that means we're only able to vary in one direction. That means that z is z, and x and y are both stated in terms of z. We're now in a position to do exercise 1E on page 44 of the 3D book.